Hello, this is Mr. Stansbury. I'm going to take you through the notes on definite integrals. At the end of this, you should be able to say, I can evaluate a definite integral using the fundamental theorem of calculus and by using a graphing calculator with more difficult integrals. Okay, so first thing from earlier, for a continuous function f of x with antiderivative capital F of x, the integral of f of x from a to b with respect to x would be f of b minus f of a. So that's the antiderivative of b minus the antiderivative of a. Okay. The antiderivative of b minus the antiderivative of a is commonly written as this here. Just this is a notation thing. So we can rewrite this here as either this here or this here. So this is just basically combining them all together. Okay, now where this is going to make, I think, hopefully a lot more sense is when we put it into an example. So here we go. So we're going to find the integral of 2x cubed minus x squared plus 6 from 1 to 2 with respect to x. And then also we're going to do this one over here as well. Okay. I created a graph here just so you can kind of see what we're trying to figure out. So we're actually trying to find out what this value here is, right? So here's the function 2x cubed minus x squared plus 6, and then here's from 1 to 2. So we're going to actually calculate what this area is here. Okay, so that's what this definite integrals is going to help us do. Okay, so what we're going to want to do here, we can hand calculate this, and we can also do this on the graphing calculator. So let's show both of those. Okay, so this over here is going to equal, we're going to do our antiderivative here, right? So plus 1 is 4, so we have 2x to the 4th over 4. Plus 1 is 3, so minus x cubed over 3. And this is x to the 0 plus 1 is plus 6x over 1 plus our constant, right? But on this here, we're actually going to leave the constant out. Okay. And then what we're going to do is from our little formula before here, we're going to do this from 1 to 2. So that's how we write that. So what we're going to do now then is we're actually going to plug 1 in for our x's here. Actually, we're going to plug in 2 for our x's here first, and then we're going to subtract the 1, put the 1 in for all the x's and subtract those two numbers, and that will give us the area under this curve here. Okay, so that's going to be 2 times 2 to the 4th over 4. Probably could have simplified this here, right? Because this is just 1/2. Okay, and we can leave that as, we'll leave that, get rid of the 1 there. Not 4, but just nothing there. So let's change that. So we have going 2 to the 4th over 2 minus 2 to the 3rd over 3 plus 6 times 2. Take all of that, and then we're going to subtract. Same thing with the 1 in there, right? So we're going to do 1 to the 4th over 2 minus 1 to the 3rd over 3 plus 6 times 1. Okay, so 2 to the 4th is what, 16? So that's 16 halves, which is 8. We're going to subtract 2 cubed, which is 8 over 3, so minus 8 thirds. Let's see, we can turn that into what, 2 2/3, or 2.667 we'll call it. Okay, and then plus 6 times 2 is 12. And then we're going to subtract all of this. 1 to the 4th is 1 over 2 is 1/2. So since we did decimal over here, let's do decimal over here, 0.5. 1 cubed over 3 is minus 0.333. And then plus 6 times 1 is plus 6. So that's 8 plus 12 is 20 minus 2.67 is going to be what? 17.333 minus a half. Let's see. So that's 6.5 minus a third. It's going to give us 6.1667. Let's see. So take that times it by -1, and then we get, there's our -6, and then we add 17.333, and that gives us 11.167. Well, 1.66. 11.16. I should do 1.66. Okay, so that's going to be units squared. So that should be this area under the curve right here. Okay. Now we can also do this with we can actually do this on the graphing calculator by simply going into math and function interval fn9. Sorry, fn int. So that's number 9. And look at that. It's going to give us our little function stuff here. So we're going to simply enter in exactly what we have here. So we're going to go from 1 to 2. Put in our function here, which is 2x cubed minus x squared, and then plus 6. Right, there's our function, and we're doing this all with respect to x. And we push enter, and hopefully we'll get the same thing, 11.166. It was 667. I just rounded everything off, so it messed up our numbers here. Let me erase that so we can actually make that so that's readable. Right, 167 units squared, which is exactly what we're getting here too. Okay. There is also one other way you can do this on the graphing calculator by pushing. You can actually graph it. That's where I got this from here. So we do 2x cubed minus x squared plus 6, and then we graph that thing. Oh, it shouldn't have that on there already. So let me do this. Okay, this is better. This is what you should end up getting if you've got like Zoom Standard here. So here's the function 2x cubed minus x squared plus 6. So we just want to find the area under the curve from here to from 1 to 2, right? Because that's what it shows there. So what we'd want to do is we want to fix our window, right? So x minimum, we're going from 1 to 2, so I'll just maybe put -1 just so we can kind of get our axes in there. X max 10, that's more than what we need. We know we're only going up to 2, so I might change this to 5. And then the y minimum, it's not going to go down below, so let's just do -1. And then if you'll notice, our graph is going up pretty quick, so I'm going to change this to 20 or something of the sort, and then do graph. It's going to regraph everything here. Here's the big thing. I want to make sure that this 2 is going to hit, and it's going to hit somewhere up there. And then here's what we do to find this area under the curve. Second trace, and we're going to do this number 7 down here. Okay, and it's going to ask, what's the lower limit? What do you want your lower limit to be? We want our lower limit to be 1, so you literally just push 1, and it will, and push enter, and it's going to give us our lower limit of 1. And then what do you want for the upper limit? Push 2, and then enter, and it's going to go through and actually shade all that stuff in here. And then the other nice part is it actually gives you the area under the curve, 11.1667, which is what we got there. Okay, so that's 3 different ways to do the same problem. By hand, probably the hardest way. You can do it with the graph, which is, if you're really comfortable with the graphs, especially with the windows, you can do that. But I'd probably suggest the second way, where we did this on our integral here. Okay, because then you can look at it and know that you got the exact thing. So you can do the same thing with the graph too. Okay. All right. Let's do. We'll just do another example here, and then a more tricky example. But really, from here on out, it's just going to be some more examples. Okay. All right. So let's put this I'm not going to do this one by hand just because it's so much quicker to do it with the calculator. So how about I'm going to do this with this our integral notation here. So I'm going to clear that out, and we're going to do math, and we're going to want to do number 9. Okay, and then this is going to go from 2 to 5, and our function is 6x squared plus 1 minus, and then you can do this as a fraction or you can do it with division. I kind of like the fraction, so I'm going to do second and then y equals, and it's going to give us our fraction piece here, minus 2 over x squared, and then this is all with respect to x, and then I simply push enter, and it's going to give us what that value is, 236.4 236.4 units squared. That's a lot. Okay, now really quick, again, you can do the same thing on the graphing calculator. I'm just gonna pause this and put that on there really quick so you can at least see the same thing there. Just reminding you, go into y equals, and we're going to enter the equation. So here's our equation. I already pushed graph once, and I've already modified my window a little bit. I need to make sure that it goes from 2, 3, 4 to 5. It does not reach up to 5. I already put my window up at 100, so I'm going to put this thing at, say, 200. And then oops, that's not what I wanted. I want this one up here. Oh, my scale. Let's do scale of, it'll make a line every 10. If we make it every 1, it's just going to be a black line. It's going to be a whole bunch of lines in there. So let's move this up to 200, push graph, see if we're close, 2 to 5 here. We want to make sure that it hits somewhere along this line if it continues to go. Sorry, my graphing calculator on here is really slow when I've got this recording going on. So it looks like it's going to hit right about there. So it looks like we're in pretty good shape. You officially don't have to see it. It's just a lot more satisfying to be able to see what's going on. So then we're going to do second trace again, and we're going to do number 7 here, which is our integration. Lower limit, we want to go from 2 to 5. 2, enter, upper limit, 5, enter, and then it's going to shade it all in for us, and away we go. So here's the pretty shading, and then it also tells us that it's 236.4, so we get the same answer regardless of how we do this thing. Okay, I'm just going to show you one more that's just really not very friendly at all, so definitely want to do this one on the graphing calculator. And again, you can do it either graphically, or really the quick way to do this is just with math. It's just kind of nice to see the graph sometimes to see what you're actually doing, but we can simply just do it on the calculator here. So we're going to go from 1 to 3, and we're going to do, this is going to be one big fraction, so I'm going to do alpha y equals, and that's going to give us our big fraction here. And we've got 1 over, I'm going to do second square root of, and we got to do the 3x minus 2 all under the root. Okay, if for some reason we, like this root ended right here and the minus 2 is on the outside, we would just simply arrow over to get out from underneath the root. But anyway, we don't need to worry about that. And we're going to integrate this with respect to x. So we do all that, and it's going to calculate us out to be 1.097. 1.097 units squared. Okay, so that's really all you need to do. I'm just going to pause this and put this in and show you on the graphing calculator as well, just to show that we should get the same thing. Okay. Okay, so really quick, here's my y equal. Graphed it, changed my window to -1. You can read there. So I changed my window just to make it look kind of pretty here. And then again, we're going to do second trace, and we're going to do number 7 here. Our integration here, lower limit, we want 1. So that's what it tells us. Upper limit is 3. And we enter that, and it's going to shade everything in and tell us our area. Okay, and there's our shaded area, and there's our 1.097, which is exactly what we got on the graphing calculator. Okay? All right. That's all we have for definite integrals. If you have any further questions, please feel free to ask. Thanks.